Hello, hello, hello. How have we all been? How has our week been? How is the preparation for the quiz? Hope you're preparing well. The quiz is on Saturday from 5 p.m. to 11 to 12 midnight. It's an hour quiz. It's objective. It's just to test like where we are so far, our knowledge, how far we have come, right? So don't be scared, it's going to be an easy quiz. All right, so let's get to today's work. So today we're going to be talking about understanding the operating systems. What are our objectives? Number one is to understand the basic concept of an operating system, describe the key functions of an operating system, identify the components of an operating system, and explain how an operating system enables multitasking. So let's get to it. So what is an operating system? An operating system is a software that manages computer hardware and software resources and provide common services for computer programs. So basically, an operating system is that software that manages computer hardware such as your CPU, your memory, your that's your RAM, your ROM, your storage devices, that's your hard disks, your 1 terabyte hard disk, 512 gigabyte hard disk. Manages all these computer resources, manages software resources as well, and provides services for computer programs. So basically, an operating system, which I'll be calling OS because OS is short for operating system, and OS is the backbone of a computer system. So if I give you a laptop, if I give you a desktop, if I give you a MacBook, and I say, oh, make use of this device I've given to you, what will enable you to see the things that you want to do or to perform the actions or the activities that you want to do with that system is actually an operating system. You get, so it is the backbone. So application programs usually require an operating system to function. Yeah, so even if you are developing an application, you are creating a very nice software, maybe you're a developer, you want to create a calculator, whatever you are doing, you need to have an operating system basically. So an operating system acts as an intermediary between the user of the computer and the computer hardware. Exactly. So the operating system is the middleman. You get the middleman. So between the hardware, the hard disk, all those components on the board, on the motherboard, all those components on the motherboards, and then the CPU, the processors, the storage devices. So the operating system acts as the middleman between those things and the actual user that wants to make use of the laptop. So if, for example, you pick up your laptop, you want to use your web browser, right? So for you to be able to click on that your web browser, browse what you want to browse, we need an operating system. So the operating system provides a user interface for the user to interact with the computer hardware. Exactly. You need that interface to interact. So the interface can either be like your GUI or the CLI. We'll dive deeper into that. All right. So what are the key functions of an operating system? Number one, we have bootstrapping. So the operating system is the first software that is loaded when a computer starts up. It initializes the computer hardware and loads the necessary software to start the operating system. So basically what it means is that for you, for example, if you buy a new laptop, right, the first thing that is going to be put into that new laptop is actually the operating system, right? So the operating system is the first software that is loaded into the computer to actually start it up. So what are the things? It initializes the computer hardware and load the necessary software to start the operating system. So it's very important. Once you put in your OS, once you put in your OS, sorry please I'm a bit distracted. Once you put in your OS, right, for you to be able to put in other things like your web browser, or you want to put in other things like your games, right? Word document, Word, Excel, PowerPoint. When you put in those things, you have to first of all put in an operating system. So an operating system like Windows, your Linux, Ubuntu, Mac OS, and the rest. But for you to be able to put in other things, you have to first of all put in an operating system, basically. So it provides a user interface. One of the functions of the operating system that it provides user interface. So what is user interface? User interfaces are things that allows the user to interact with the computer and its resources. So it can either be graphical user interface like what you are seeing here on, like when you open your laptop, especially if you're using a Windows device, right? What you see is your GUI, your graphic user interface. And then there's also something called your command line interface. So that is when you do use your command prompt. So command prompt is your command line interface. Yeah, command prompt is your command line interface. So there are actually some operation system that they don't have GUI. If you go into the if you like sign in, if you open the system, you're just going to be presented with the command line to type the code that you want to do to execute what. In fact, some Linux servers, most Linux servers serve don't come with GUI, just present the say coming with GUI. Don't come with GUI. You will type your command and make sure that and you can with your command of course you can do basically everything that you're doing on your GUI, even and more. I guess say and more. You get. So we have process management. The operating system manages the execution of computer programs. It creates and destroy processes, schedule processes to run on the CPU, and allocate resources to processes. So basically, when you open an application, maybe you open Word document, a process is created for that Word document that you have opened. So process management is a function in the operating system that allows it to manage which process is to be run and scheduling the processes, scheduling a runtime with the CPU for these processes. So basically, if you open, for example, you open your Word document, you open your web browser, you have two different processes. So process management is what helps your CPU know that when you click on Word document icon, it is Word document process that should be run. And when you click on the web browser icon, it's the web browser activities process rather that should be run. So it is that process management that performs such function. Then we have memory management. The operating system manages the computer memories. It allocates memories to processes and ensure that processes do not interfere with each other memories. For example, now let's say you open your let's use our Word document and web browser at the same time. So you open your Word document, you are typing some things that are supposed to be stored into the memory, and also you're using your web browser. So your web browser like writes into the memory as well, store the history of what you have been doing. So memory management ensures that the memories of these two operations, of these two processes you are working on do not clash with one another or do not write into each other. They write in their own specific ones. Then we have the file system management. So this operating system provides a file system for storing and organizing files on the computer. So obviously, like when you are using your computer, you need to store some of your files. You need to store your video files, your text files, your different files, your picture files, and the rest. So that's file when you go to File Explorer, that File Explorer that you see is a form of file system management. So the operating system is the one that is in charge of um, providing a file management system. You understand? Different operating systems have different ways that they manage their files. All right, so let's move. What are the other key functions of the operating system? We have device management. So the operating system manages the computer hardware devices. It provides drivers for devices and allows application to access devices. So basically, you know that for example, when you get a laptop built, they'll ask you that you need to install some drivers, right? You need to install your trackpad driver, you need to install your mouse driver, you need to install keyboard drivers, you need to install if you have touch screen, you need to install the touch screen drivers. So what manages all these drivers, right? These drivers are what enables like these hardwares to run, right? So what manages these drivers is called the device management system. So The operating system or the OS is in charge of doing this. Then we have security. The OS provides security features to protect the computer from unauthorized access and malicious software. So whatever operating system we are using, if you go to settings, you see a part concerning security. You understand? So this is what the OS is in charge of. So we have networking. It facilitates network communication, allowing computers to connect to the internet, share resources, and communicate with other devices on a network. So with operating system, they can be able to connect with other networks, right? There's an option. If you go to the settings of any operating system you are on, there's an option concerning network that helps you to connect with other devices or the network. They help you to connect to the internet, that help you connect to other resources and all of that. So networking is a key functionality of an operating system. The next one we have is error handling. So the OS handles hardware and software errors, aiming to prevent system crashes and providing error messages to users or administrators when issues occur. So for example, maybe when you're trying to install something, you see a pop-up that shows, oh, there's an error with this, an error with that. So the OS is in charge of handling these errors, right? It handles these errors to prevent your system from crashing. So when it sees that, oh, this thing's overheating, I need to close some applications, do you get? So this is the responsibility of an operating system, and then it provides these error messages to like the administrator or the user. So let's say you're trying to install something and maybe when you're installing it's not compatible with the operating system you have on, you get? So it will give you a notification that what you're trying to install is not compatible, you get? So that it will prevent you from even trying to install it in the first place, to prevent it from crashing, you understand? Because it might have allowed you to install it but then everything will crash. But the goal is that it will give you that error first so that you will know that okay, this is not compatible, so that you won't end up installing it and crashing the system. So the operating system, that's the OS, handles error handling. And the next one is task scheduling. So task scheduling, it manages the execution of multiple processes and decide which programs run when and allocating CPU time fairly. So basically, task scheduling is more of like this. Let's say you have like you are trying to do three different things. You are working on a Word document, you are using your web browser to browse like the details that you want to work on your Word document, and then you also want to play music in the background. You understand? It's suiting all those suiting music, right? All right. So when you start doing that, the goal of the operating system is to schedule these different processes, right? They are scheduling these different processes in the sense that, let's say for example, you click on your Word document tab, it knows that okay, it's time for this Word document. It gives this process, like it allocates, say okay, CPU, it's time for you to do this particular Word document task because this user has clicked on this Word document task. Do you get? So the goal of task scheduling is that it allows different processes to run simultaneously so that it gives the illusion of multitasking. So it allows different processes to run. So as you are doing this, you can still do this, you can still do that. So that's basically the function of operating system. Alright, so this is more of like a diagram. So we have the CPU, the memory, the devices, and we have the kernel, and then we have the applications. So this is an operating system architecture. So what are the components of the operating system? So we talked about the OS, the OS, the OS. So what are the things that you can see that you know that okay, all right, this is a component of the OS. So number one, we have the kernel. This is the heart of the operating system. It manages the hardware and provides essential services to other parts of the OS and software application. Right? It handles tasks like process management, memory management, device management, system calls. So the kernel is the heart, the cocoa. This is what you don't see. This is what It is there, but you don't see. This is the heart of the operating system. It manages the hardware and provide essential services to other parts of the OS, right? And the software application. So you can dive more into this kernel. So there are inside this kernel, there are different types of kernel depending on the particular operating system. So it's very, very important to try and understand more about the kernel. Now the next one we have is file system. The file system component is responsible for organizing and managing files and directories on the storage devices. So we've talked about this. One of the key features, or one of the key functionalities of operating system is file system, or file system management. Now we now have a file system. So each operating system, or each OS, different OSs makes use of different kinds of file system. What is this file system all about? Basically, if you have like you're using a laptop, you're using a system, and you want to store different files, and you there needs to be a way of managing these files. Do you get? There needs to be a way of storing these files. Like you don't want it to just be random, random, random. So the way by which you store these files is called the file system. And different OS have different file systems. We have the NTFS for Windows, we have the ext4 for Linux, HFS Plus on the Mac OS rather. So you can dive more, understand this file system better. Then we have this process management. We've talked about this one so many times about how it is responsible for creating, scheduling, and terminating processes. So the goal is that it wants to ensure that all the processes that need to be run are run. Like, pardon, all the processes that need to be run should be run at like a good time. Like everything should be run concurrently. You don't want that when you are clicking on Microsoft Word, nothing will come out for you. That's not what you want. And that's why sometimes you see that your screen will be rolling, 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 and it's turn white because of it's trying to, maybe the process management is kind of slow, right? It's trying to schedule, and the transition and everything is making it slow. You get? But the goal of the process management is that it wants that every process that it needs to run should be run. Right? It doesn't want that, okay, you need to run this process, that's a program, but it won't work. You understand? So that's the point of the process management system. So it includes things like process creation, scheduling, inter-process communication, so on and so forth. Then we have memory management. Memory management involves allocating and deallocating memories for processes and ensuring that they do not interfere with each other's memory spaces. So basically, it's like this, right? Every application that you run on your device requires some sort of memory to work, right? So you need to allocate memories for each process. Maybe when you start your Word document, particular amount of memory is allocated for that Word document. So that whatever you are writing, whatever you are doing is being stored in memory. That is why, let's say for example, you are writing your Word document and you did not save it, and then it closed, maybe you close it, what do you call it? You sha got closed and you didn't save it. There's a way on your particular laptop that you can go to go and find that Word document that you did not save. There's a way to find it there inside you don't need to do for inside your computer. There's a place to find it. So that means it's being stored in the temporal memory, because once you restart that system now, that memory is gone because you didn't save it. But if, for example, you didn't save that Word document and you've not restarted that laptop, there's a place to go and find what you did not save. Very simple stuff. So that's the and all these things happen because of memory management. Because memory management allocates memory for each process that is going on in your computer. For everything you are doing, there's a memory attached to it. Memory management ensures that these memory spaces do not conflict with one another. You get? It does what it just ensures that they don't interfere with each other, you get. So the next point is device management. So this component manages input and output devices such as your keyboard, your mouse, your mouse, it is this later, your mouse, your printers, and your storage devices. So basically, you remember I talked about like drivers, right? Drivers are um Drivers are things that enables you to make use of these physical components that you have. So you need your keyboard driver, you need your mouse driver, your trackpad driver, your printer driver, and your storage driver, all those kind of stuff. So it's supposed to ensure or help you to make use of these physical components. So the device management helps manage all these devices. So we have user interface. So we talked about this. It's also a component of the operating system. It's what enables users to interact with operating systems. It can be CLI, which is the command line interface, where you are using text-based command, where you need to type a command, you need to do like maybe dir, you need to type something, right? Or it can be a graphic user interface which requires you to use like your what they call it, your mouse. Is mouse driven, so you need to, it's more of like clicking, you have icons and stuff like that, you can see some stuff. So we have network and communication. This is for systems that support networking. The this component handles network connection, protocols, and communication between devices. Then the next one, we have security and access control. Security components are crucial for protecting the system and its data. So they include things like user authentication, access control, encryption, security policies to safeguard the system from unauthorized access and threats. All right, more components of like operating system. We have error handling and logging. Operating system handles hardware and software errors and provide mechanism for logging and reporting them. So error error handling and logging. So we talked about this before. When the operating system helps like handle errors, right? When error comes up, it pops it up to the administrator. Sometimes it even suggests what to do, you understand? Suggests what to do when you experience this kind of error. So it helps the administrator to diagnose error and quickly resolve whatever issue that is ongoing. So we have utility and system tools. Operating system also often come with set of utility tools that assist users and administrators in tasks such as power management, system configuration, troubleshooting. So these utility and systems tools are things that come inbuilt that enables the user or that enables the administrator to perform some specific activities. And maybe they are trying to troubleshoot, there are things that are inbuilt that can help troubleshooting, things like your task manager, your control panel. Control panel is also for system configuration as well. There's just so many things that you can use that come inbuilt so that you can use to figure out what is going on in your system. And we have system libraries. These are collections of pre-written code that provide functions and routines for software development. Application developers use system libraries to interact with various OS services and hardware components. So another component of the operating system is the system library. So for programmers, right, that when you are creating code and you need them to interact with or the particular OS, you can make use of these system libraries, you get, so that your code or your function can interact with the operating system. Then we have file and directory services. This component manages the creation, the deletion, and organization of files and directories. It enforces access control. By the time we talked about least privilege, rich privilege principle, right? Access control. So if maybe you want, if like yours, this particular system has multiple users and you want to allocate different access control to different people, it is file and directory services that enable this. So it enforces access control, file permissions, and file system maintenance. So we have the last one for components is interpreter, command interpreter, which we can call it shell in brackets. So in systems with command line interface, the shell interprets and executes users command. So that's the command interpreter, which is the shell. It interprets and executes the command written by the user. So for example now, if you want to list out all the folders that are in your command line, you use something called dir if you're on Windows. So if you use dir, right, on your Windows, and it lists everything out, so the shell has done its work. The shell has taken in the command that we wrote and interpreted it and executed it and brought out what we want to see. You get. So the next thing is how OS enables multitasking. How OS enables multitasking. So multitasking is a fundamental capacity of modern operating system that allows a computer to run multiple programs or tasks simultaneously. So there's for modern operating system, there's an illusion of multitasking. Why do I say it's an illusion? Because really, they can't necessarily, the operating system or the CPU cannot do more than one thing at the same time. You understand? So that is why we are calling an illusion of multitasking. So how does this multitasking work? How can you say, okay, this laptop is multitasking? Let's break it down. Number one, processes. A program is often referred to as a process. When you open a web browser, when you open a word processor or a game, each of these is a separate process. These processes are like individual jobs that the computer can work on. So if you open your web browser, if you open your Word document, if you open a game, you've opened three different processes. Now the next point is CPU time sharing. Now so this is where I'm talking about the illusion of what they call it, the illusion of multitasking. So a computer's central processing unit, which is the CPU, is the brain of the computer and it can only work on one thing at a time. So that's why I said that is an illusion because the CPU can only work on one thing at a time. But listen to this now. However, it works very quickly and can switch between tasks so fast that it appears as though it is doing multiple things at once. So because of the fact that tasks, it can switch tasks very quickly, it appears like it's doing multiple things at the same time. So the operating system divides the CPU time into tiny slices and assign each process to a turn to and assign each process a turn to use the CPU. This is called time sharing. So what happens is that the operating system will divide the time of the CPU to different tiny slices. So that it can share itself, right? Okay, I'll use this we'll work on this work document for 5 minutes. Switch to the web browser. Switch. Switch. Something like that. So it's sharing the CPU's timing. So we have process scheduling. The operating system uses a process scheduler to determine which process gets to use the CPU at any given moment. It considers factors like the priority of the process, how long it has been waiting, and whether it's waiting for input or output. The scheduler makes sure that each process gets a fair time of the CPU's time, gets a fair share of the CPU's time. So we have the process scheduler. So the process scheduler determines which process um which process the get to use the CPU at any given time. So for example, you are running a report on the background, you are running a recording stuff on the background, you are running different things on the background. So the goal of the process scheduler is to schedule which one is supposed to be happening at a certain given time, right? And it looks at the priority of the process. Okay, is the user actively using this now? If the user is actively using this now, definitely it should be high priority. So how long has this particular process been waiting for? Has it been waiting for long? Then also, what exactly is this process waiting for? Is it waiting for an input? Is it waiting for the user to input something? If it's waiting for the user to input something, if the user have not imputed, it will take a step back and keep waiting. Is it waiting for an output? If it's waiting for an output, then that should be top priority. Do you get? So all these things like the process scheduler takes into consideration while determining which process gets to use the CPU. All right, so we have context switching rather. When it's time for one process to stop and another to start, the operating system performs a context switch. This involves saving the state of the currently running process, loading the state of the next process, and passing control of the CPU to the next process. This happens so quickly that users typically don't notice it. So what exactly is context switching? Let's say for example I've opened my Word document and I'm opening my web browser, right? And I want to go from my Word document to my web browser. Maybe I'm trying to do copy and paste, copy and paste. So I copy from my web browser, I paste on my Word document. Now I want to go back to my web browser and copy again. So once I click on my web browser, this context switching happens. So what does it do? It stops the process on the Word document. It saves that process and then hands over the control of the CPU to the web browser. That's what it does. So it's called context switching. So it switches from one process to another. When there's a change in process, it switches from one process to another. And we have the I/O operation. I/O stands for input slash output. So while one process is waiting for input slash output operation, like reading from a file or waiting for a user to click a button, the operating system can switch to another process. Do you get? This ensures that the CPU is always doing something useful, even if one process is temporarily blocked. You understand? So once there is a need, maybe it needs an input slash output need, it wants to read from a file or is waiting for a user to type something or click a button or something like that, it switches to another process. You get, it switches to another process. Then we have the user interface. The operating system often provides a user-friendly interface like a graphics desktop, which allows user to interact with multiple applications. User can switch between open programs and OS manages the multitasking behind the scene. Like we talked about, when you're using different applications at the same time, your OS is the one that manages everything behind the scene. In simple terms, think of an operating system as an efficient traffic cop that directs the flow of traffic. So just think of it as a traffic warden. So it directs the flows of traffic, which is the processes on the CPU, making sure that everybody gets a turn and the computer remains responsive and capable of running multiple programs at the same time. This is how you can have a web browser open while listening to a music and writing a document and running other programs on your laptop without a noticeable slowdown or interference. So basically, the operating system is what ensures that the CPU can handle multiple things, can seemingly handle multiple things at the same time. You understand? Because of the whole task scheduling, process management, context switching, and the user interface, the IO operation, because of all these whole different components, it gives the illusion that the CPU can perform, that the CPU is a multitasker. You understand? Can do more, can perform multitasking. You understand? So that's basically how your OS enable multitasking. I hope this is clear. I hope you understand this. Yes, I hope you understand it. All right, so what are the types of operating system? So operating system can be categorized into several types based on the various um, criteria, including their intended use, their design, and the characteristics. So there are different categories, right? So operating system can fall under different of these categories. So number one, we have the single user operating system. So we have number one, we have single user, single taxing. These are simple operating system designed for devices that enable one task at a time. They are not common on general purpose computer but might be found in embedded system or other specialized devices. So basically, we have single user, single taxing. Single user, single taxing simply means that you have one user to a particular device, and that one user can perform only a single function or a single task at the same time. So it's more of like from embedded devices or older devices that would have this kind of thing. Then we have single user multitasking. So this is when a single user can run multiple applications simultaneously. This is like things like your modern operating systems now, your modern laptops, modern desktop, and the rest. So the next one, we have multi-user operating system. We have multi-user single taxing. So this one is rare, but can still be found in some legacy systems that allows multiple users to access the system but only run one application at the same time. This is rare. Multi-user single tasking. That is, multiple people can make use of this operating system but can only perform one task, one application at the same time or at a time. Then we have the last one, which is multi-user and multitasking. So this is multiple user can make use of the operating system and they can perform multi-tasks. So what does that mean is that things like your Linux, your Windows servers and the rest. For a server, you can create multiple accounts for that server, right? And each of those multiple accounts can perform multiple activities, multiple tasks. So that is multi-user multitasking. Hope it's clear. So we have the desktop and server operating system. These ones, we have like the really popular ones. We have the Windows operating system, so which comes from the Microsoft family of operating system for desktop and servers. We have Mac OS, which is comes from the Apple family, and then we have the Linux, which is the an open source and it's a Unix-like operating system available in different distributions for servers and for desktop. So then we have the mobile operating system. The mobile operating system, we have things like the iOS, which is the Apple, which is from Apple family. Things like your iPhones, your iPad have them. And we have the Android. So Android was developed by Google, and then we have a wide range of mobile devices. We have the Samsung using it, we have the Techno, we have the Infinix using it. So we have a lot, like almost all phone brands, right? Apart from Apple and some other few and a few others. Most mobile brands make use of Android. Then we have the Windows Mobile. So Windows Mobile was developed by Windows for mobile devices, but this one has been phased out. Is Windows 10 Mobile that is now like the current one. So these are like a few of the most common mobile operating system and desktop and server operating system. So other types of operating systems, we have the real-time operating system. These are designed for systems that require predictable and immediate response to inputs or events. So some of these are embedded systems such as can be used in embedded system rather. They can be used in embedded system, in robotics, in aerospace and industrial control. Then we also have embedded operating system. These are used in embedded system and IoT devices. So these ones are specific to embedded systems or IoT devices, that's the Internet of Things devices. So some of the examples are VxWorks, Free, RTOS, and Microm UC/OS. So basically, these ones are for embedded system and IoT devices. Then we have virtualization operating system. So virtualizations are used to manage virtual machines. So when you think about virtual machines, it's like having another device inside your own device. You understand? Let's say, for example, you have a Windows OS. I want to get a feel of how the Linux OS works. I want to get a feel of how the Mac OS works. What do? You create a virtual machine, use things like VirtualBox or use things like VMware, right? I think we should do a class on setting up a VirtualBox or virtual machine very soon. And when we do things like this, you now like install your Linux, you install your Mac OS, or you install the Windows version that you want to see. You understand? And some of these operating systems are the VMware EXI, ESXi, then we have the Microsoft Hyper-V, and we have Docker. You understand? So the next one we have is distributed operating system. This coordinates multiple interconnected computers to provide a unified computing environment. So for this distributed operating system, it's more of like connection of different computers, you understand, to provide a unified computing environment. Things like your Google Chrome OS and some server operating system for cloud computing like your AWS, your Google Cloud, your Microsoft Azure, you understand. So we have the next thing we have is operating system interface. So for the operating system interface, we have basically the operating system interface is a way for users to interact with the operating system. Right, we talked about this. Okay, how can I interact with the operating system? Either I use a graphic user interface, that is something that I can see, feel, touch. Like I can look at it, I can see icons, you understand? I can click with my mouse. Or I use a command line interface, which is something that I have to type, write commands so that I can see what I want to get. So we have the command line interface. So this requires users to type commands to interact with your operating system. The CLI are often used by system administrators and other experienced users. So basically, using your command line is very important, especially if you are going to cybersecurity. You will get to be able to perform some activities, right? Some servers don't even have a GUI. You have to make use of a command line operating system. So a command line interface rather. So basically you need to learn how to make use of this. It might require a little bit of learning curve, but it's very important to know how to use your CLI. So we have the graphics. This one that we're seeing here is a Mac graphics interface. So which allows users to interact with the operating system graphically. You see icons, you see menus. It's easier to learn and to use than the CLI. So How do operating system affect our daily life? This is one of the discussions. Have to think about it. Oh, how does it affect our daily life and everything? How can operating system be more secure? Yeah, so what is the security in place for operating system? And I talked about the fact that with operating systems you can go to their settings and see things about security. So look through it. Okay, how can operating system be more secure? And then how does an operating system enable multitasking? We talked about it. So there's an illusion of multitasking. How will the operating system ensure that the CPU can multitask different activities? Yeah. So let me show you guys a bit of the command line. All right. Hope this should be clear enough. All right. So let me see if I can make it. Okay, let me just work with this. All right, so let me just show you a little bit of how to use the command line, and we need to do much more. So for example, if you want to list everything that is in this folder, you can press dir and you can be able to see everything in this folder. If for example you want to create a new folder, you can do this command, make directory, and put your folder. Then you can put dir again and you see it here. You understand? But if you want to remove it, you do this to remove it. Then you do your dir again and you see that it's no longer here. You understand? So this is just the basic, very simple stuff on how to use your very simple stuff on how to use your command line. This one that we need to learn how to use. It's not that difficult and all of that. So if you have any questions, please drop it here. Right? I've not really seen any questions, so hopefully please drop your questions. Then our assignment, you need to compare different types of the different desktop operating system. We have the Linux, we have the Windows, we have the Mac OS. Then just learn the basic commands on CLI, command like how to list all files in a folder, how to create, how to edit, how to copy, how to remove and delete a text file. So take a screenshot, put it on the Word document, and then look at this is a link for you to go to just read a little bit about the CLI, right? All right, thank you guys very much. Have a very wonderful and blessed day. Bye.